For this assignment, we're going to use graphs in order to evaluate some different functions and also look at some of that algebra of functions. So for the very first one that we have here, looking at this graph, it says we want to find f plus g of 3. And so we need to figure out really what f of 3 is and what g of 3 is, and then add those together. So remember with this notation, it's just telling us, okay, if my input is 3, that's my x value, what's the output? So I go to my f function, which is this one, and I want to look when x is equal to 3, which is right here. Where am I? Looking at this point, it's at 3, 0. So that lets me know that f of 3 is equal to 0. Then I need to find out what g of 3 is. So g of 3, again, it's telling me when my x value is 3, what's going on with my other function. So g of x is this other pink function, and it looks like when x is 3, I'm at a y value of 1, so 3, 1. That means g of 3 is equal to 1. So if we add these guys together, we're going to get 1 as our answer. Alright, for the next one, part 2, we're looking at g minus f of negative 1. So again, this means we want to find g of negative 1, then we're going to subtract f of negative 1, and we're going to do this all from looking at the graph. So first off, g of negative 1, we're going to look at that pink graph here, and when we have an input of negative 1, you can see on the graph here we're down at negative 2. It has the point negative 1, negative 2 on it. So g of negative 1 will be negative 2. Then we're going to look at, I'll erase some of this so we don't get confused. Alright, we're going to look at f of negative 1. So f of negative 1 means, again, my input is negative 1, so still looking at that same input, but I need to go up to that blue function, and it looks like an output of 3. So it has negative 1, positive 3 on it. So f of negative 1 is 3. Again, this is the x value, it wants the y value. And then we're going to subtract those guys. Negative 2 minus 3 will be negative 5. Alright, for part 3, again, I'm going to erase all this so I have a clear graph here. For part 3, we have g dot f of 4. That little dot means multiplication. So really, all this is saying is g of 4 times f of 4. So we need to find out what the y value is when we input an x value of 4. So if x is 4, looking at my picture, x is 4. For g, I'm going to go up to that point right there, which will be 4, 2. So g of 4 is equal to 2. Now f of 4, that's looking at the blue function, same input. So I'm going to look at the blue here, and that's at 4, negative 1. So really it's just adding the y values that you see there together, or multiplying them. So this will be negative 1, and then we'll multiply. That'll equal a negative 2. For part 4, it has this little division bar going on. That really is going to mean f of 4 divided by g of 4. So f of 4, we already know, is going to be equal to negative 1. And then g of 4 is equal to 2. So it's going to be negative 1/2. For part 5, we're going to change this up a little bit and not look at an x value of 4. We're going to look at an x value of 1. Now notice on this notation here that we have an open circle. That's composition, which really is about substituting. So we're going to substitute 1 into g. So we need to input 1 into g and see what we get. And then whatever we get, we're going to plug into f. So g of 1, I go to the g function. At 1, the g function is at negative 1. It's 1, negative 1. So g of 1, this whole chunk of stuff, outputs, let's see, if you plug in a 1, you get negative 1. So now we have to take negative 1 and plug that into the f function, or see what our output is when we input negative 1. So I'm going to go to my f function, and when I input negative 1, it's up at 3. Negative 1, 3. That means f of negative 1 is equal to 3. So remember, that's the way composition works. It's really a bunch of substitutions. So 1 goes into g. Whatever we get out of that goes into function f. For part 6, it's the other way. So remember that composition is not commutative, which means that it will not equal the same thing. What G composed with F means something different than F composed with G. And I'll write it with that other notation if you like that better. So really it means we're going to plug F or 5 into F, get an answer. Whatever answer we get gets plugged into G. So F of 5. We'll go back to our original graph, erase all the extra stuff going on, and we want to find out what F of 5 is. So our function F is the blue one, and when we plug in an x value of 5, we're going to get a -2. So we know that 5, -2 is on the graph. So F of 5, that whole chunk, is equal to -2. So then we're going to take G of that new input. So G of -2, we're going to go to our G function. -2 puts us down at -2. So G of -2 equals -2. All right, and we have one more, and that's for part 7. It is the same kind of thing. It's a bunch of substitutions because that's really composition. It just doesn't have it written as that open circle. So you start from the innermost parenthesis, and we want to find out what F of 3 is. So if we go back, let me erase some of this over here on our graph. And so F of 3, we're going to look at our F function at an input of 3. That's going to be right here an output of 0. So 3, 0 is on our graph. So if we go back, F of 3 is 0. So then really what we want to find is G of that 0. So G of 0 means go to an x value of 0 and see where our G function is, which is the pink graph, which is -2. So G of 0 equals -2. So hope that helped just a little bit more with that notation and being able to read from a graph.